So today we start with the unit vectors. Supposing in scalar numbers, suppose we have a scalar quantity, say mass. Mass is 10 kilogram. This can be written as 10 into 1 kilogram, where 1 kilogram is the unit and this is the magnitude of the mass. Similarly, in case of vectors also, we can write vectors and their magnitudes and unit vectors. Suppose there is a vector A, displacement, suppose this is a vector, displacement vector, 10 meter east. This means we can write this as 10 into 1 meter. This is the unit vector and this is the magnitude unit of the vector A. Okay, this is the magnitude of the vector A. Okay, so we write this vector A can be written as its magnitude. So the magnitude is written under 2 bars. This is the magnitude of A, and its unit is written as A cap. This is the symbol of unit. So this represents unit, this represents the magnitude. This is the unit of the vector A and this is the magnitude of the vector A. Okay, so it means unit vector of A can be written as the vector A divided by its magnitude, because A is actually the magnitude times the unit. So the unit vector of A can be written as the vector divided by its magnitude. So we usually take symbols of unit vectors along x and y, x, y, z axis as usually, it's not a rule, that usually or generally we take unit vectors along the x, y and z axis by symbols I, J. We usually denote unit vectors along x, y and z axis by I, J and K. So if we suppose A is a vector which has a magnitude 3i. It means this is a vector whose magnitude is 3 and it's directed along the x-axis. Similarly, if you write vector say B, say 4j, means this is a vector along the y-axis with having magnitude 4. So suppose there is a vector A 3i plus 4j. This means that this vector has one of the component, its x component is 3 and y component is 4. This is yes, suppose 3 units along, so it is a vector 3i. Suppose this is I units, so it is 3i here, and 4j is along this axis, y axis. This is x axis, this is the y axis. It is 1, 2, 3, 4, 4j. So this vector represents the vector. A has two components. X component is given by 3i, and y component is given by 4j. Or you can say this is the ax I plus 4yj, where ax is given by 3 and ay is 4. Now, suppose we have another vector b, and it is 2i plus 5j. This is another vector having its amplitude along x-axis as 2 and along y-axis it's 5. Now if you want to add these two, you know that the x, in order to add, we resolve all the vectors into their x and y components. The sum of all the x components gives the resultant, x component the resultant, and sum of all the y components gives the x component, y component the resultant. So here we have already x components given. So it means sum of the x components is 3 plus 2i. This will give the x component of the resultant vector, and 4 plus 5j. So this is 5i plus 9j, and this is your resultant vector a plus b. The x component of the resultant is given by 5 and the y component is given by 9. So if you want the magnitude of r, all you have to do is rs square plus ry square under root, so it's 5 square plus 9 square under root. And the direction is given by ry by rx, so the tan theta, if it's suppose the angle is theta, it is 9 by 5. So in this way we do the addition of by vectors. If we addition of vectors by unit vectors, if the vectors are represented in unit vectors. So okay. So similarly you can add and subtract also. So it's just you have to do your practice for addition and subtraction. Now we'll do the multiplication by unit vectors. So we have two types of multiplication. Sorry. Dot product and cross product. Sorry. So suppose we have in the dot product, what we do is a dot b. That was AB cos theta. Now suppose A, if you have just taken A as 3i plus 4j and B is 2I plus 5j. Now here to take the dot product of these two. It means 3I plus 4j dot 2I plus 5j. 3 into 2 is 6 and this is I dot I plus 3 into 5 is 15 I dot j. Now 4 into 2 is 8 j dot I plus 4 into 5 is 20 j dot j. Now I dot I is a unit vector along the x-axis, which means it has a magnitude 1 and directed along x-axis, and this one is also directed along x-axis. This means 6 1 into cos 0, that is 1 into cos 0. Why? Because both are parallel, the angle between them is 0. So it is the magnitude of I is 1, magnitude of this I is also 1, and the angle between them is theta. This is AB cos theta. So it's AB cos theta. So similarly here, I dot j 90 with each other. So it will be 1 into cos 90. Similarly, 8 1 into cos 90 plus this is 20 and j dot j is again parallel, so it is 1 into cos 0. Now cos 0 is 1 and cos 90 is 0. So these two terms will vanish and we are left with 6 plus this one 20. So it is 26. So the dot product of A dot B is 26. Means in the dot product I dot I and I dot j, I dot I is parallel and I dot j is makes 90 degrees, so they can finishes. So this is the way to add, we multiply dot products. So the multiplication of unit vectors, suppose the multiplication of unit vectors. Suppose first we are doing dot product. So it is I dot I. It's 1 into cos 0. This is 1. So it is j dot j. Again 1. K dot k is again 1. But I dot j and j dot k and k dot I will give you 0 because they are making 90 degree with each other and cos 90 is 0, so there. So it's easier to remember that the same, if you want dot product of the same unit vectors gives you 1 and different one gives you 0. Now cross product. Is I cross I. And we know that A cross B is AB sine of the angle between them, and this is a vector. This is the magnitude of the vector, and the cross product results in a vector. So it's suppose this is a vector, say it's in the direction n, unit vector along the way. This has the magnitude, and the direction is, and this direction is perpendicular to the plane formed by the vectors A and B. So it follows the right hand rule. So I cross I means 1 into 1 into sine 0. This results in 0. So similarly we can write that I cross I is equal to j cross j is equal to k cross k is 0. Now suppose I cross j, I cross j is 1 into 1 into sine 90, and sine 90 gives you the value 1. Now this is a cross product. It means the product is also a vector, and the direction of that vector must be perpendicular to both the plane formed by the vectors I and j, and must follow the right hand rule. Suppose this is along x-axis and this is y-axis. So if this is unit vector I, this is unit vector j, I dot j means you have to use the right hand rule convention. Put your right palm on the first vector, rotate the fingers along the smaller angles to align along the second vector. The thumb will point the direction of the cross product. So it is I, first vector is here I. So I am putting right hand here, my right palm, rotating the fingers along j, thumb is pointing outward the blackboard. So this is k, y z axis. So it is along k. If this is x-axis, this is y-axis, and this is z-axis. So it is along z-axis. So it is, you can write simply as I cross j as k. Similarly, we can, if you invert this, say it is j cross I. It means you are putting your first vector is here j and the second vector is I. You have to put your right palm on j and rotate fingers to align along I. So you have to put your right palm like this, so as to rotate through smaller angles. So it is I, and the k points inside the cross product of j cross I points inward, which is minus k. So I dot j is, so similarly j cross k will be I, and k cross if you reverse this k dot j will minus I, and I cross k will be minus j. K cross j, j cross k, j is here. Put your right palm. K is outside the board, so it's towards I. Correct? Similarly, k cross I, k is on this side, and I, so j is k, and the reverse of this is minus I. So in order to remember this, what you have to do is, suppose I is kept here, j is here, and k is here. This you are multiplying I with j, results in k. J cross k results in I. J cross I results in j. If you reverse the direction, j cross I, it will be minus k. I cross k minus k cross j minus I. So this is the process of multiplication of unit vectors. So we can suppose we have the same two vectors which we have taken, taking the we have A was, we have taken A as 3I plus 4j and B was perhaps 2I plus 5j. I am taking the cross product of these two. So 3I plus 4j cross 2I plus 5j. So here 3 2s are 6, I cross I plus 3 5s are 15, I cross j plus 4 2s are 8, j cross plus 4 5s are 20, j cross j. So the I cross I means 1 into 1 into sine 0, that is 0. 0. I cross j gives you k, it is 15k, and j cross a gives you minus k, and j cross k is equal to 0. So it is 15 minus 8, that is 7. That is the cross product of these two vectors results in a vector which is perpendicular to the plane outside the board, so having magnitude 7. So this is the way to. Now I will do this one more problem. Suppose we have two vectors, A as 3I 4j minus 2k and B as 4 8j plus 7k. First we will do dot product and then cross product. So A dot B means we are multiplying these two. So it's the first 3 into 4, that will be 12. I dot I is 1, so it is 12. This I dot j is 0, so this will give 0. I dot k is also 0 because they are 90 degrees, so all of them 0. So j dot I will be 0 and j dot j will be 1, so it is 4 8s are 32 and j dot k is also 0. K dot I 0, k dot j 0, k dot k, so it is minus 40. So the answer is this much. 4 minus, that is 30. Now we want to take the cross product of these. Cross product means A cross three I plus 4j minus 2k cross 4I plus 8j plus 7. Okay. So 3 4s are 12. I cross I plus 3 3s are 24. I cross j and 21. I cross k plus 4 4s are 16. J cross 4 are 32. J cross j, and 4 7 are 28. It's minus sign here because it's minus here, and k cross. No, it's not 28. This is 7 2s are 14. Okay. Sorry. 7 to the 14. No. It's a J term. Okay. Sorry. It's okay. This J is multiplying, so it is 28 J cross K. 28 J cross. Now this one multiplying it, so it's minus 2 multiplying with 4, that gives you minus 8 K I, K cross I. It's again minus 16 K cross minus 14 K cross K. Okay. So all of them have been multiplied individually. Now I cross I means 1 into 1 into sine 0, and sine 0 is 0. So this will be 0. So the first term is here 0. Now I cross j, and we have just learned that I cross j was k. If you, in order to recall, you can write like this also. I, j, k. This, if you move along cyclic order, I will give, cross j will give you k, j cross k will give you I, k cross I will give you j. So it is I cross j will give you k. So it is 24. K, and again I cross k, it means you are moving anti-clockwise, so it is minus j, so it is minus 21. This is our minus, okay, and j cross I against, so it's minus k, minus 16 k. Now j cross j is again 0. Parallel vectors, sine 0 0 plus 28, and j cross k is I, so it is 28 I. K cross I is again j, so it is minus 8k, and k cross j is minus, k cross j is a reverse of this, so it's minus I, so it's minus plus, it's 16, and k cross k is again 0, so it is k. So you get I here 28 and here 16, so it is 44. And j minus 21 here. Oh, there is a mistake. I cross j is k. I cross k is minus j, okay. J cross I is k, and j cross k is I, okay. K cross I, just here, it's k cross I, this is j. So it's k cross I is j. So it is 21j here and 8j here. It means this is minus 29j and 24k here and minus 16k here. 8k. So this is the resultant of the product of A cross B, which is a vector having components along x, y and z axis as 44, 29, 8 respectively. So this is the way to multiply the cross product. There is another method also, and we will check that whether our answer is correct or not. And another way is like we have to multiply, take the cross product of A cross B. We write like determinants. We take I here, J here, K here, and I's. First vector is A. A has come 3. This has 4. K has -2. B has values 4. J has 8. 7. So first if you take I, you remove these two, these rows and columns remove. So it is multiply this and with this with minus sign in. So these two are hidden. 7 4s are 28, minus 8 2s are 16 and plus, so it is plus 16 I. Now if you are working for J, you hide these two rows and columns. So 3 will multiply with 7. So it is J. It has 3 to 7, 21, minus 4 into minus 2, minus, it is plus. And now K, rows and columns of the K is hidden. You multiply this 8, 3 8s are 24, minus 16. So you get 44 I minus 29, okay, plus 29 J plus, sorry, it's minus here. Minus here. In the determinants we use plus, minus, plus. So this is plus, this is minus, this is plus. So it's plus, minus, plus. So it is minus 29J, and this is again 8K. So this is the same result as we have obtained here. You can take any process, either the determinant process or that simple process. So all these about unit vectors and how to add and multiply using unit vectors. Take the cross product and dot product. In the next class we will do some problems on the vectors, and that will finish our vector chapter. Okay, thank you.